Okay, so we are today in the second part of Chapter 8, Section 5, Exponential Growth Functions. And the first thing I want you to do is try this little homework quiz, and that is to write the equation for this table. So pause the video, see if you can do it, and come back and you can walk through. Okay, if we weren't in this section on exponential functions, the first thing you would want to do is see what kind of a pattern you have. Do we have a pattern in the domain? Yes. Which variable represents the domain? Which variable? X, right. So these numbers here, are they in a pattern?
Yes.
So consecutive, so that's good. So now we're looking for a pattern in the range, and what is it, Selena?
Divided by 2.
Okay, so she says divided by 2. Divided by 2. But yesterday when we said that there is something commonly found in a pattern for exponential functions, we didn't say division. So could you write this as a form of multiplication?
Yeah,
what would it be? You could times it by 1/2. Good. Because these two are equivalent, dividing by 2 is the same as multiplying by 1/2. We're going to use the multiplying by 1/2 because we know that we're writing an exponential function. If you see division, division, division by the same factor, then you are also looking at a exponential function. Okay, and we change that to multiplication because first of all, let's write the model for an exponential function. Can you say it? Can you say it?
Y equals plus.
Good job, okay, good. So this repeated multiplication represents which letter in the model?
The 1 is A.
No, the repeated multiplication here, 1/2. It represents the B, good. So we wouldn't write at B, we wouldn't write divide by 2, right? We're going to write multiply by 1/2, you see? So that's why we're putting that in there. Okay, so I'm going to make some room here, and we're going to put 1/2 to the x. Now the question is, x and y remain open to all the possible points, right? The question is where, now this is what you guys were just saying, where is the a in this function? And the a is what you get when you plug in what number for your exponent? When you plug in 0, which gives you a 1 here, right? So when we plug in 0, the 1/2 becomes 1, and y equals 1. So what number goes in front of here? 1. And then because it is 1, do we need to put it?
No.
No. We can leave the equation y equals 1/2 to the x. But I do need to correct one thing. This doesn't look right. What do I need to add? Tara. Very good. Parentheses. Because otherwise it would be only the 1 that's being raised to a power. And we know that that does nothing. I mean, 1 to anything equals 1. So that doesn't help us. Make sure you have a fraction, if it is the base, in parentheses. Okay? Okay, very good. Who was able to get that before we did it here? Excellent. Now I bet you'll all be successful with this one. Try this one. If you're doing this on the video, pause and come back. Let me just say that most people right away could find the B, which makes sense, right? Because what is the common factor you see here?
Times 4.
Times 4. That is your B. Okay? So when we write the model, we have 4 to the x. 4 to the x. But when you plug in, like, let's plug in, we don't have the 0 in the x as far as in this table, right? You don't see 0 here. It goes 1, 2, 3, 4. Or in this direction, it goes 4, 3, 2, 1. So 0 could be added here, right? But if we're going to go this way to get to 0, what are we doing? We're not multiplying by 4. What are we doing? Dividing. So what's 2 divided by 4?
1/2.
1/2. Or 0.5. Some of you wrote it as 0.5. So we are going to replace the a with 1/2 times 4 to the x. And when we test this out, it works. If you left this as y equals 4 to the x, a couple of you, I said, what if you just test this point? When you plug in 2 here, what is 4 squared?
16.
16, that's not 8. Do you see? So you could use a given point like this. You don't have to go back to 0. You could use this point. You could do this. You could say, I don't know what a is, but I know that y is 8 when x is 2, right? And so 4 squared is 16. And now could we divide both sides by 16?
Yeah.
Yes. And you could get your A that way. A is 1/2, right? A is 1/2. So if you don't want to go backwards in your table to find your y-intercept, it's a y-intercept, isn't it? On the graph, then you could just plug any point in. Once you know your B, plug any other point in for x and y, and you will find your A. Okay? Good. So hopefully you did well with your homework on that. So today we're going to take exponential functions a little further and talk about the exponential growth model. So let's make a big rule box for exponential growth. This is a common equation used in finance and in the business world. We hope that when we put money, let's say, in the bank, we hope that it grows this way, because exponential growth look like these, right? As the x's increase, as your x's increase, your y's increase. So imagine putting money into the bank. Here, you put some money in the bank, and it, over time, grows. And it doesn't just grow linearly. It grows, we hope, exponentially. So it gets really steep. You get greater amounts, okay? So that's what we're looking at. The same is true, I was talking to the other class about businesses. So the most common business these days, which we know has grown tremendously fast, is what business? Okay, Starbucks. In your lifetime, Starbucks. Or what else? Apple. Or what about even Samsung, even some of the Android makers, right? Those things have been growing exponentially. And the challenge those business people have is, if this was Apple in the year 2000, and now Apple's up here, how do they maintain that growth? Do you know what I'm saying? They've expanded so fast. They are sitting in meetings and saying, how do we keep growing? Because that's what we want to do. We want to keep growing. And that's a difficult thing in business. I mean, it's a wonderful thing to grow like that, but then how do you keep that momentum, you know? You got to come up with something new and fantastic, I guess, each time. So, okay, so this function is increasing by the same percent now over time, okay? So when we look at this function, we have all these different pieces to it. And the A, which looks like, this looks like A times B to the X, right? You see how it's related? The A is the initial amount, okay? The initial amount. Okay, so we have the initial amount here. Okay, the R stands for the word rate, right? And the rate is the percent, okay? So the growth rate, the percent you're sticking in. This entire thing in here, this entire value, when we add 1 plus R, is called the growth factor. The factor by which the entire value is growing. And then little t is, like, very good, it's time, the time period in years, okay? Okay, let's see how we can use this in a real world model. Okay, so there is a person who found an original 1938 comic book, and you need to take these notes down so you have one good sample. But an original 1938, it's almost 100 years now. 100 years old. Comic book sold at an auction in 2005. The owner bought it for $55 in 1980. And this same owner is selling it in 2005. The value of the comic book increased at a rate of 2.8% a year. So the first thing we'll do is write a function that shows the value of the comic book over time. Okay, using our exponential growth model. And then we'll actually calculate the value of the comic book when he sold it. Okay, so you're going to want to practice using the growth model that we just learned and memorizing it. Often you will receive it, it'll just be handed to you in a standardized test, but this is such a commonly used one that you want to be so familiar with it. So let's just write the model down. Y equals A, the initial amount, 1 plus R, our growth factor, to the T, okay? So what do we have in the word problem here that can fit into this model? Do we have an initial amount? What is it? 55. So we're going to put 55 for A, $55. And the 1 stays there, okay? And the reason the 1 stays there is kind of interesting. I'll show you that in a second. But what about R? Do we know R? What is R? And Lauren is saying 0.028. Does that make sense to everybody?
Yes.
Good. When we drop the percent sign, we move the decimal 2 place values to the left. Very good. And then do we know the T?
Yes.
What is the T? Does anybody else have it? What is the T? It is 25. So he bought this thing in what, 1980? And he sold it then in 2005. So he had it for 25 years. So we substitute 25. Yeah. The question is, would you be given a calculator? And the answer is absolutely, because you would never be asked to take 1.028 times itself 25 times, by me anyway, maybe by somebody else, but not by me. So we're going to use a calculator to do this. But when we add 1 plus 0.028, what do we reduce that to?
1.02.
Okay, to the 25th. We're going to practice using the calculator. And we're going to answer this question. The question is, what is the value of this in 2005? Okay? So when you use the calculator, keep in mind we've got parentheses here. Is the 55 being raised to the 25th?
No.
No. So make sure that when you input the 25, that you do it just for the 1.028. If you don't know what you're doing, listen to this. If you don't know if you're using your calculator wisely, could you do 1.028 to the 25th, press enter, and then multiply it by 55?
Yes.
What property allows us to switch that order? Commutative property of multiplication. So if you're insecure, do this part first, and then multiply that answer by 55. If you're using our calculators, the ones we use at school, you just input exactly as it is here. 55, open parentheses. You don't even have to press times, okay? The number, close parentheses, exponent to the, and then fill in 25, okay? Okay, so if you've input the value and you rounded to the penny, the answer is the comic book in 2005 was sold for $109.70, which is pretty awesome for the guy. He made over, 100% of his money. He made he got his 55 back and he made another 55. Almost, right? Okay, so I wanted to show you one thing. This 1 in the equation is really what percent? What is 1 as a percent? It's 100%. It's 100%. So look at what happens. If we had the same equation and he did not have let's say he did not have 2.8% growth. Let's say he had no growth. We could say 1 plus 0 is what? Is 1, right?
To the 20.
And what is 1 to any exponent? 1. And so if this comic book did not grow by any percent at all, what is it worth in 2005?
That makes total
You
sense.
see, it's 100% of what it was in 1980. Okay, so the 1 inside of here with your growth factor, the 1 represents the whole original, and then you're adding 28% or 2.8%, whatever it is. This was 2.8, not 28. This was 2.8. Okay? So that's an important concept for you to understand. The other time you'll be asked about this is with compound interest. Compound interest is a great example of exponential growth. And so you will use this just replacing your A with the amount you're investing. Okay?